our seminars about different types of monitoring and of air pollution and geo-monitoring, two types of different ways of monitoring for control and coping of different natural risks. And who start? I don't see John.
If John is not here, I can start some. It's not a problem. Okay. 1 minute. I will share my screen.
Gleb, please try to start. And I try to make and to mail message to John.
Okay. 1 minute. I will share my screen.
Okay, no problem.
Where is it? Here. This one. Sure. Today I will present a presentation about influence and air pollution and how we are providing to demonstrate to the society this pollution. As a table, our project has 4 basements. First basement is airports, where we searching some information about flights, about time, status of flight, and number of flight. The second one is airplanes. Each airplane has some characteristics like weight, number of passengers, fuel, engine, and distance which this airplane can fly, for what kind of distance. The other one is coordinates. It's important to know longitude and altitude to present our result on the map. And the last one is calculation. We must calculate emission for each airplane. As a result, we have a data migration. Of course, this some data migration includes sometimes dictionary. As you can see here on the screen, we have 2 different systems, like International Air Transport Association. They are providing one standard how to classify airports and flights, and we have at the same time another new one classification, International Civil Aviation Organization. They're providing a new classification, and sometimes when we use different services, we must know what kind of classification we must apply or translate to the other classification. As a result, for example, sometimes you can find some information from the airport. You can find one information like flight, number of flight, and it can be first standardization. And when you want to find coordinates, it can be the other standardization. Then it's about airplanes. We must retranslate sometimes different metrics like liters to kilograms when we talk about fuel tank, and retranslate other measures. And as a result, we can apply this data migration and calculate and have a result. This is website data sources. Here you can see in second column is airports, top 10 airports of the Russian Federation, which is providing a lot of passengers in the year. It's statistic from the last year. It's statistic from 2019. And total, when we calculate it, firstly, when we started work with this, we tried to calculate covered hours system. Like, for example, it was the first step which we did to understood we can do it or we couldn't. And as you can see here, in total, we have 154,000 million passengers from this top list airports. In total, in Russia, it's around 190 million passengers per each year. I can say this covered is around more than 75%. After that, we decide we can create this kind of system. Then we create some data migration files, where we will find information and from which kind of source. For example, here you can see, like, first source is airport information desks, where we can scan information about flights, data, and status. Then if we will know flights, we can find data about flight, from where, name of airplane, is at least model of airplane, Airbus, Boeing, or the other one, kilometers, which this airplane already passed in this day, and coordinates. If we will know coordinates, we will know information about how many points we have, and it's like longitude and longitude and altitude points, how many we have. And if we will know which model of airplane, we will know all information about emission. It's less emission, but we know is we are sure that emission was, and we can predict some emission. It can be, but we are not sure. And I must say in this step that all our calculation was theoretical calculation. This is first view for our program software. As you can see, we decided to use which kind of database. This is web crawler is like open source framework, which provide to us possibility to scan all web page in internet, our operation system, and this is server where we did it. For example, let's talk about web crawler. On website, you can see online information desk from airport Domodedovo. Here we can find information about time and all information which is interesting for us. For example, when we are scanning this web page, we are finding some information about status, and as I already told you, about flight status and time. Then, if we will use, for example, sometimes it's a different kind of web pages. Sometimes if you want to know about model of airplane, you should go to the other one pages. You can follow, you can find URL link on this web page, and you can follow to the other, to the next web page, and take some information from that web page. Then you extract all this information, and then in items you can cut some information and have information which is important for you. For example, sometimes when we're extracting some information, we can have tabulation or the other problem with information. And here it's like a filter. And after it, we can create, after this, we can create a file, which then we will analyze with the other tools. The second question is about coordinates. Here on the screen, you can see perfect coordinates from the same airport, from airport Domodedovo to the other airports. We have the other source, the same. The source is illustrated to us from Domodedovo, where is going airplanes, and which the other airports, which the other airports these flights is visiting. As you can see here, it's flight radar 24. Firstly, we try to understand, because it's like a perfect trajectory, and here it's not perfect trajectory. If you will open flight radar 24, you always will see that trajectory sometimes demonstrate different figures, and it's important to know real figure. And here it was first idea what we can analyze, because here, as you can see, latitude and longitude is presented. But when we wrote a message to them and asking them to their support provide to us and share with us some information, they said that they're presenting all information and they're demonstrated online, and it's dynamical data. They are not keeping those data. As a result, we found the other one web service is FlightAware. Here you can see one example. It's Aeroflot flight 10, number 10, from Sheremetyevo to St. Petersburg. It's at least day when it happened. Here you can see speed and the other metrics, and as the result, you have a flight list where you have information and all coordinates and total all information from that flight. For calculation, we used formula from International Air Transport Association. Aeroflot modernized that formula, and we understood how it works, and we can provide this formula for our software. For calculation, we used these parameters. For example, this number of seats, how many numbers of seats, how many seats we have: economical class, business class, and first class. As you can see here, we have two variations of airplane: Airbus A319. First variation is when total list of seats, total seats is 154. In the other situation, 124. Flight distance is maximum distance of flight. It's 6,800 kilometers. It's a fuel tank in liters. You can see here again two variations. And flight again tank fuel in kilograms. If translate this to kilograms. And this is max flight weight. Here's max commercial weight of airplane. And this is a coefficient of seats, which is changing each month, because this coefficient always submit organization in the country which work with statistics and which calculate how many seats was empty, and they're providing this coefficient for each month. As a result, we can see we create a table. This is more than 15 airplanes, and you can see all emission which we calculate for airplanes. It's less emission and max emission per 100 kilometers for a passenger. Here we demonstrate a little bit about our server, operation system, and the other configuration of server. And at least we used program language Python and MongoDB for storage our data. As a result, in backend, we've created this scheme, and here you can see different models. First, it's we have here 3 crawlers, which is working with different in different time. For example, one crawler and one line is working 1 month. It's coefficient of seats. This line is providing find new information about coefficient of seats, and it needed just one time in a month. And the other crawler, for example, this one, is working with 10 airports, and he is searching information and providing to us information about time, flight, status, and URL from where that information. And then it's a filter which identify each flight and status of them. For example, if it was cancelled, it wouldn't become here. And here we have list of flights. Then second crawler is using this list of flight, and he is searching information according with this list. After that, he is creating backup of the day, and he is putting all this information to filter 2, and in this filter we have a mess where we can calculate some information if we know about coefficient of seats, CO2 from airplane, and how many kilometers airplane passed. As a result, we have again here is debug, and this filter working is working every day, and we have a flight file of flight data, and then we're doing every day recording in a database. This is his first recording in a database. It was at least maybe 1.5 months ago. At least you can see here 574 flights. It was in Russia is normal flights, it's 4,000. Right now we have in Russia just 1,500 flights every day. And this 574 we have 1.5 months ago, when it was peak of coronavirus pandemic in our country.
Mm-hmm.
After that, we create a time diagram where we have time when model must start to work and different kind of models. For example, Able Archer, it's a debugger, and at the same time, it's after-run model. He is running the other models. Python Py, it's a crawler. Specific test Python, it's a first filter. Again, crawler, filter, and this model, as you can see, sometimes we use one line, 1 month, and sometimes if it's not the first date, program is skipping this process and going to the end. And last one, push, is model recording in a database. In the database. Here UML diagram how it works, and if it will be emergency stop of program, how our program will finish the process. It's total how it works, how it's running, and if it will be a problem, what kind of the end must be. Here's a log where you can see some information, like when it starts, when first model, all models is starting. This models is not working because it's not first date of month. And our this software generates this text every day. Here we have in our mail feedback from software. If something will go wrong, we will know about it. Let's talk about a little bit about front-end. This you can see tools for developing that front-end and some tools for testing, which we used to create that program. Here it's a technology and libraries which we use it. As a result, we have this. It's just a prototype of software, but we have a map where we have trajectories. Each trajectory has information from where, flight, data, airplane, way, and about fuel, how much it was wasted. The other possibility to present information, and the last one. The last one we're using when we want to know about information from points. For example, as you can see here, we can select from, we can choose a time and select, and it will present to us information, and it will calculate from few days which we choose here in our filter. For example, this is information for the last 3 days. On the last 3 days, from 7 May to 9 May. This is at least we can we have one more filter. We can choose 2 flights from one airport to the other one, and we can add a new flight here, but not more than 10 flights. And again, we can work with data and select which which gap of time is interesting for us. At least we have a square to select special information which can come to this square, and we can present information from this square and calculate information from all points which can come to this square. In the future ideas, we're planning flat air flats, which they are using what kind of airplanes. Then we want to provide statistics about each company, about their airplanes. For example, what average years they're using airplanes, what kind of airplanes, their pollution, and present to people how companies from the last year was changing their airplanes flat, and how they're providing better things to the environmental. At least right now we are working with just with our territory, I mean with Russia. We are planning to do the same kind of service, firstly to Europe, and secondly to Asia, then to Africa, and the last is for total for South and North America, and for Australia. That's all. Thank you for your attention. If you have any question, you can ask me.
Thank you very much, Hlib. Maybe Denis want to add something, or that's it?
Not thanks. I not at all for this presentation.
But thank you for support and helping for preparing and for made solution before. And I'm glad to see Leonid Valentinovich in our group. And Gleb, thank you for operative solution and for report. As for me, I have no question. And thank you for addition of flight statistic that depends on coronavirus. It's really interesting. But now I think, colleagues, are there any question? Okay, I think we continue, and maybe after second report, there are more questions, and question for first report too. John, if it's possible, please start.
Just a minute.
No problem, we are waiting.
Hello everyone. I was late. Yeah. So my name is John Okwaro. A student at Taveta. My proposal is on geo-monitoring of carbon dioxide emission decline due to COVID-19. Yeah. So let's start. So these are the agenda. There's introduction. There's objective, methods and materials. Have discussion. Conclusion, then references. So this research is in line with 4 sustainable development goals. These are a good health and well-being. That's sustainable SDGs, SDG 3. And there's affordable and clean energy, which is 7. And there's SDG 9, the industrial innovation and infrastructure, where we encourage the innovation in green energy and energy efficiency. There's also the most important one, which is climate action. Carbon dioxide is the most important greenhouse gas. Of course, it's because of its long lifetime in the atmosphere. Of course, there's methane, which is also an important one, but then methane stays shortly in the atmosphere. So carbon dioxide remains the most important, especially when you are talking about a long period like 100 years. The main source of this is the fossil fuel combustion. So fossil fuel has become a problem because of when we talk of air pollution, I think we cannot leave a fossil fuel out. Yeah, because here we have carbon monoxide being emitted, there's methane also, then there's nitrous oxide. But this research will focus on carbon dioxide and its effect. Yeah. So Nairobi city is a fossil fuel city. It means that most emissions is due to the fossil fuel combustion. And therefore, if we can reduce the fossil fuel combustion, then we're likely to see less concentrations of carbon dioxide and other gas that may cause air pollution and other hazards to human beings and the environment. So on 6th April 2020, there was a partial lockdown in Nairobi metropolitan area. And these were, according to Dr. Adero's research, there was decline in human activities due to the partial lockdown. And therefore, it's expected that the concentration of carbon dioxide will also decline. So the observation this that said declined from this bit, yeah, which means that there was increase in human activities again, and therefore there's increase in carbon dioxide concentration.
Excuse me, John, maybe you push F5 button for full size of slide, if it's possible.
So, just a minute.
It's not so necessary, but it's more comfortable if it's possible.
Yeah, sorry.
Okay, maybe it's not necessary because slowly internet and maybe this says good. Okay. Oh, thank you. Very good.
Yeah. Sorry. I'm in a remote area, so there's a problem with. All right, so our study area is the Nairobi metropolitan area. So for that, so this is the area. So our area of interest, especially is this Thika area. There's also the Nairobi, the city itself, because there's industries at the city. There's an industrial area in the city here. Thika, there's an industrial park, and also here at River, there's also mining industries there. So those are very interesting areas for this research, and of course the transport system, because of the emission of these gases when vehicles burn the fossil fuel. So the area is 32,000 kilometers square, the population of 9 million. So these are the objectives. The general objective here is to develop the concentration, carbon dioxide concentration trend model for the Nairobi metropolitan area for the period between 1st November 2019 and 31st July 2020. And then we simulate post-lockdown concentrations from August 2020 to August 2021. That's a period of 1 year. Specific objectives to determine changes in concentration of carbon dioxide due to the partial lockdown. Of course, to predict the growth of the concentrations in the near future, then to develop a carbon dioxide concentration trend model that can be tested at any time within the period. Sorry. Research questions here. We'll be looking at the trends of concentrations, of course. There's also the factors that drives that are important in predicting the growth, and also the mechanisms and how these mechanisms combine to drive changes in concentration of the carbon dioxide in the region. Our data collection period is from 1st November, like we've seen, of 2019 to 31st July 2020. Our data will be downloaded from the NASA mission website, and our data is the orbital. Is the fraction, the mole fraction of carbon dioxide, the mole fraction of carbon dioxide in the air, denoted as XCO2. So it's a secondary data. So the scientists who download this data from satellite, and then they validate it against the ground-based network. Yeah. So whatever we are downloading is the secondary data. Our data files come in hierarchical data format, and therefore we open them in HDF view, which will form our database. So we'll also be looking at the transport and industrial fuel consumption to see the trend, if the trends are consistent with whatever our data from satellite will be giving us. So that's how also 3 measurements occur. Because of the carbon emissions by a plant, for example, like a coal plant or cement plant. Yeah. So our database, like I said, is a HDF view. So here we can get all the files can be read through this, and so we can get our data from this platform from the HD view. So if you want your data, you just go to retrieval results. Yeah, you double click on it. You go to X. You see the X CO2. You click on it, you get your value. So our value here, like we said, our data is a fraction of air. So the fraction of carbon dioxide in air, and therefore it's a mole fraction, that is moles per mole. So if you want to get your value in parts per million, you multiply it by 10 raised to power 6. So collection of data, one, like we said, we'll download it from the NASA emission website. So our data will be a level 2 data because this one has had errors removed, and of course biases also removed. So it's a good data. It's the data that we need. And we download using the wget software. The release stratified, purpose even direct sampling for the case of transport and industries, so that we cannot like use all the industries to collect data. So we use this statistical method to get a few industries, but we make sure that there's the spatial coverages, right? Yeah. So the research will also carry out interviews in case the records of fuel consumptions are missing. So you can carry out interviews of the operating employees to get to know the records, to get to know the amount of fuel that was consumed each month. So we also use the GPS to get the locations of these industries and of course the petrol stations for the case of transport system. Sorry. So I was looking at the preliminary data. I was looking at the months of April and May. So on 16th April, the concentration of carbon dioxide was 419 parts per million. On 2nd May, it was 410 parts per million. 24th May, it was 411 parts per million. 30th May, it was 413 parts per million. So you can see this given the trend there, the concentration was reducing, then at some point it started rising. So, but because the data collection period has not yet elapsed, I've not collected all the data. So I'll be doing that. And then the analysis will be in our software environment because it's a time series analysis. So in this case, we'll be looking at two scenarios that will help us this research will be giving two scenarios based on mitigation measures that will be taken. So there will be first there will be the business as usual scenario where if mitigation measures are not taken or nothing is done, the current activities that human beings are doing, then what will be the concentration maybe in the next 1 year. So that will be, if nothing is done, so what will be the concentrations? And then we'll have another scenario, the optimistic scenario, where mitigations measures that this research will suggest are put in place. So if those mitigation measures are put in place, so what is likely to be the concentration of carbon dioxide in the next 1 year? So that's so we'll be looking at the two scenarios so that we can use them to advise the authority, the county government, and the government, and the national government. So some of the mitigation study area that we've seen the government take is the reclaiming public forest, land, and reforestation. So there's the forest, the Ngong forest, people have invaded the forest, so the government is trying to reclaim the land and because we know that of course we are carbon dioxide in the atmosphere. Of course, there's also the non-motorized transport system. So in this case, the government is constructing walk path and cycling path for the residents of the study area. And this one, of course, is to avoid is to decongest the city. Of course, if people can walk or ride bicycles to work or when they are going to the city, then they will avoid going to the city with the vehicles, and that means that we are helping in the reduction in the fossil fuel that is burnt, which means that we are decreasing the air pollution that we see today. Then, of course, there's also mass rapid transport. The government says in 2 months we shall be seeing construction of this pathway for the mass rapid transport. And of course, just like the non-motorized transport system, this one is will also help in decongesting the city, and therefore few vehicles means few fuel combustion, and therefore it means that there's little air pollution. Yeah, so some of the proposed mitigations measures proposed by this research, one of them is the clean energy strategy. Of course, we're looking at, even as we talk of economic recovery, we also need to see clean energy being incorporated in the economic recovery. So clean energy here, we are talking about the use of solar energy, the use of wind energy, the use of geothermal, hydro. Yeah. So instead of using the fossil fuel for energy, we can use this other. And the country, Kenya, has made a big stride in this. For example, it's the leading country in geothermal production in Africa. Yeah, so it's really doing well. But then geothermal, of course, it's limited to the Rift Valley area. So yeah, so it's a limited entity here. Also, there's hydro. We are doing fine. There's also wind energy that we're also doing fine. We have part of it in Turkana, and of course, yeah. So in Gong Hills, there's also wind power generation. So the country is doing fine, but then it needs to do more, especially in terms of solar energy. Yeah. So innovations, of course, the government should support innovations by partnering with private institutions, so that to make sure that we have like energy efficiency, for example, installation of pumps and ideas like that. And also, of course, in the green energy. So we need innovations. So the government should support those innovations that see efficiency in energy and, of course, green energy. There's also policies. The government should structure policies that see they see improvement in terms of energy, in terms of green energy, so that we have policies that support the green energy and try to suppress the use of fossil fuel. For instance, the government can decide to remove the incentives in fossil fuel, like we have been saying, and then they increase like tax on that, so that people now avoid using the fossil fuel and focus on the green energies. For example, solar. And then there's also public participation. So you can give it to the government for doing some of this, constructing some of these infrastructures. the government has not done enough in public participation and public awareness. So it needs to do more in public participation and awareness so that even the public themselves embrace this idea of clean energy and support by, for example, buying solar panels and using the energy to heat homes and use at home for electronics and things like that. So yes, we can do that. And all this can be done through systems thinking. So we know that all these are connected. Yeah, so there's policies, and of course, there's partnering with the private institutions. So you have to involve the private sector in all this, so that, because if the government decides to do this alone, most probably it will not succeed, or it will take longer. But if it includes the private sector, they can also come up with innovations that can see clean energy so that we avoid this air pollution. And of course, in line with that, of course, eradicating fossil fuel completely may be hard. So we can also have innovations that improve the capture of carbon dioxide that is produced in the industries. So these are some of the ideas that the government should be putting across and trying to make sure that they happen. So if all that happen, of course, there'll be help for the people, improved livelihoods. There's also the economic part where we have jobs being created by these technologies that will be put in place. So yeah, so all this we need the system thinking to solve this problem of air pollution and climate crisis. In conclusion, in 2009, we had almost a similar problem, a similar situation like we are today, where there's a drop in carbon dioxide emission due to economic crisis and decrease in GDP. But nothing was done to take advantage of the situation. And therefore, in 2010, there was increase by 5.9% in the concentration of carbon dioxide, which means that as the economy, as the countries strive to recover their economies, if this idea of green energy is not put in place or is not embraced, then we are likely to see a rebound in concentrations of carbon dioxide and other air polluting gases going higher. So it's very paramount that that this idea of green energy is embraced by the governments, not just in Kenya, but across the world. Yeah, so it's a very good idea and it should be embraced. Like today, you know that in UK they are now looking at constructing the largest hydrogen gas companies the company for production of hydrogen gas. So they are looking at using hydrogen gas as an alternative to fossil fuel. And I think Germany has embraced that too. Germany has embraced the idea of solar energy. You know, so it's an idea that I think all the governments in the world should really embrace. With the models, the models that will be developed in this research by this research will obviously be used by other countries in the other countries, because in other cities in Kenya and of course other countries that have fossil fuel as their major or main source of energy. So the recommendation of this research is for the government to invest largely in solar panel or solar energy, because Kenya is an arid and semi-arid country. Of course, we have areas that are arid and which are very low population because people do not like living there due to the adverse climate. And adverse climate, in this case, we are talking about high temperatures, there's high solar. So people avoid these such places, and therefore have a large piece of land, or a bigger area that is not okay. There are no settlements there, and therefore the government can decide to clear such land and install solar panels, which will then give enough energy for the country. So they also be encouraged to install solar in their homes. So by doing so, they'll be saving a lot, and of course, solar is cheaper as compared to the other source of energy. So that's the recommendation of this research. So those are the references. And thank you for listening.
Thank you very much, John. Really interesting and detailed report and presentation, and major idea of our two reports, it's air and its new instruments and tools and models in air monitoring and geo-monitoring, because it's the most reason for many exogenic risks, as we said before. And one question from me, if it's possible, about clean energy strategy. About governments, what type of data prefer? Optimistic scenarios, negative scenario, or realistic? What's preferred data or different data for building strategy?
Sorry, I didn't get that clearly. Kindly repeat. I was having internet problems.
Of course, about building clean energy strategy of country or of Africa. What's prefer scenario or data? Negative, positive, optimistic, negative, or realistic data, or all types of data?
I'll go for realistic.
Realistic. All type and really real integrated situation. Okay, for realistic vision. Okay, understand. Thank you. Good. Colleagues, are there any question for John or for Gleb too?
Sir, I'm really having a problem getting you. Just a minute. Could you kindly repeat your question?
About me, I think you answer about realistic data. And that's it. About the other question, colleagues, please. Colleagues, are there any question about problems, pollution, and maybe about new instruments and calculated of problem?
I think I didn't get that too. Kindly repeat.
Okay. Leonid, do you have any question?
I don't think so. Maybe just to compare with other satellites, and with ground-based measurements. Maybe ground-based measurement of CO2 would be more precise.
Understand. I think maybe for improving and development research, John will use the other data from MESOR 3 or the other satellite mission, or as a recommendation, not question. Okay, as I understand, our master students before asked the question, and now there are no. Alexander, do you have a question?
No, I haven't.
I think really more detailed and full report for start ideas for research, and I think that's it. Maybe the other colleagues have a question. Okay, as I understand, that's it. Thank you very much, John. Really interesting, and I believe and I hope that we organize new project with our students, and maybe we prepare new joint reports and presentation, and maybe we will report the new project with different the other information. It depends on about condition, and I think it's really interesting and important research, especially in carbon taxed condition and building of new form of taxes, and with political and virus situation. Nation, maybe for finish you show for other colleagues COVID models, if it possible.
Yes, yes.
Your slide, because
Thank
it's
you.
interesting. Yes.
So, can you see what I'm sharing? So, in Kenya, I've been doing modeling, and I remember you shared my work sometime back. And now I can say we have reached a stage where I have what I call a compact model, such that we know the range within which the COVID cases can be estimated for policy and planning purposes in Kenya. So beginning from 30th June, the green line is the trend which we had before reopening. The president eased restrictions, and from 6th of July, that is here, we reopened, and you can see after 2 days, the actual number of cases, the black line, went up. It went above the former simulated path. This was the path we were following before when I simulated it to a coefficient of determination, which is high, 0.9984. So you can see the trend is going up. And what I call the yellow line, this yellow line is the lower trajectory, if you are expecting the cases to grow by 3.8% per day. But if things go worse, we can go up to 4.5% per day from what we observed from previous data. So by the end of the month, that is July 31st, we are expecting over 20,000 cases if we go by this trend, the yellow line. But if there is carefree attitude, we can go to the red line of over 25,000 cases. And the president will address the nation on Monday after meeting, because we can see very clearly that reopening has led to an increasing number of confirmed cases in Kenya. We are already at 14,805 today, which is above the projection of 14,687 today. So this is a tool we are using for policy and planning. And I've done a similar compact model for Russia. And now I want to show for Russia, you can see how the same modeling technique is informing the scenario in Russia. So let me just share the one for Russia. So this is Russia now.
It's very interesting for us because they are the vision.
Yeah, for Russia again, I've come up with a compact model. I began from 18th June and studied the trends. So the green line is the trend that was simulating the cases in Russia, but you can see the black line is the actual cases recorded. For example, by 21st July, yesterday, you had 783,328 total cases. And you see it is staying very near to the green line. And the green line is projecting that tomorrow, that today, 22nd July, you could have around 790,000 total cases. And by August 1st, if the trend continues, about 843,000 cases. The red line is showing when the cases were growing fast in Russia at an exponential rate of 1.05% per day. But it seems that from this date of 10th July, this upward trajectory, the trends left the upward trajectory, and the cases were showing a decline. The graph is now bending downwards. So it seems that it's very likely that Russia will not register more than 900,000 cases by August 1st. Then this polynomial line, the green line again, when I do again the first derivative, you find that the coefficient of x is negative, which means if the cases continue like this, then there's a tendency that it will reach a peak and start going down. And when I equate this one to 0 from 18th of June, I find the peak of Russia to be November 20th. So that Russia is likely to reach the peak on 20th of November. So that is what this compact model is revealing, and it will be interesting to compare this with African cases and the cases in Kenya and help to validate the model. And after that, we can see if we can produce a paper under the expeditious Geo-monitoring team. Thank you.
Thank you very much, Neshan. As for me, I'd want to believe in optimistic scenario about situation in Russia and in Kenya too. But about real model, maybe it's not so good, but it is not million. And I believe that there will not so much cases, and maybe we will use new vaccine, or maybe there are other new tools for positive situation and for good trends of development of COVID situation. But we're talking about this, and maybe we prepare new seminars about COVID, because now we have to report about air and geo-monitoring, but we can't fix it data from Corona and from COVID, but we can see and we can fix and research data as results, as air pollution, as geo pollution, and as ecological risk and mining risk and the other situation. And new tools really interesting, and I think it's very good that our student, our postgraduate student, and your master student try to research the situation and try to build new scientific models and new forecast about control and about understanding situation and different type of using satellite and aero data and building new base and base of knowledge. Okay, thank you too. Thank you very much. Colleagues, are there any question? That's it. I think that evening time and maybe all colleagues tired. Thank you very much. I'll post all records to YouTube channel and to official site of our group, and I'll prepare the official mail for John. Thank you very much. And I think we continue join research and we prepare a new seminar. As for me, I'd want to prepare a new seminar about exogenic risks and different reasons. About COVID situation, good idea too. Maybe after 2 months we prepare real situation and real forecast about and can control about October and November. Because now we see forecast, but then we can see real situation.
Real situation, yes.
Mm-hmm. And thank you very much. Now I stopped our conference. Colleagues, thank you for participation and have a good evening. Thank you very much. Thank you. Bye-bye. Okay, see you later in new seminars. Okay, bye.
Bye.